it is Wednesday, April 30th, and it is day 23 for us in Algebra 2. Yesterday I was not here to teach you this lesson, so we're going to review it a little bit. The do now was to work on the exit ticket, and if you had completed it, to start working on this worksheet. So now we're going to move forward and look at this worksheet together. I am going to label this as Algebra 2, day 23. Okay. So, on Monday, we talked about graphing equations. Yesterday, you guys supposedly talked about systems of equations. So, let's just look at how we would do these together. I'm going to pull up my piece of graph paper here, and I'm going to copy this problem down. So for number 1, the system is y equals negative 5x plus 2 and y equals x minus 4. So let's start here. First of all, whenever you learned how to do this yesterday, what did you learn? Whenever we are solving a system by graphing, how do you know what the answer is, the solution? Yes, you're going to graph both of these lines, and wherever those lines cross, that is your answer. So let's start graphing one line at a time and see where it takes us. So for the first equation, y equals negative 5x plus 2, where would I start to graph this line? On my y-intercept. What is my y-intercept? 2. That number at the end is our y-intercept. And the y-intercept is on the y-axis. So we'll start right here at 2 on the y-axis. Okay, so where do I go from there? Yes, now we need to use our slope, and I heard you say down 5, right? This number right here beside the x gives us our slope. So because it's negative 5, that means we're going to go down 5 from that point. So 1, 2, 3, 4, 5, and then what do I do? I'm going to go over 1. Why am I going over 1? Why am I going over 1? Why don't I just go down 5 and I'm done? Yeah, so anytime we have a whole number, like negative 5, this is a whole number, our slope is also our rise over our run. So our whole number is negative 5. That tells us to go down 5 for our rise. And any whole number, because there is not a number at the bottom of a fraction here, to turn that into a fraction, we always just put it over 1. So when there is no run, we always go 1. Okay, so I have down 5 over 1, and this is my second point. So I've got my 2 points. What do I do last? Connect the dots. I'm just going to take my ruler, and you want to be really precise with this. Make sure that you're landing in the middle of the dots. If I were to graph it over here, it's hard to tell, but that little bit of being off, not right through the points, is not going to be the correct line. I need to make sure I'm right on those intersecting parts. So there is my line. Right there. So I've graphed my first equation. So now let's look at the second equation. I have y equals x minus 4. So how would I start graphing this one? Bless you. Say it again. How do we start graphing our second equation, y equals x minus 4? What do we do? Yeah, we're going to start again with our y-intercept, which in this case is negative 4. So I'm going to go on the y-axis down to negative 4, and I'm going to make a point. Now, I know my slope is the number that's next to x, but there's no number here. What does that mean for our slope? It's 1. Anytime there's not a number next to x, that number is 1. The number just tells us how many x's there are. There's negative 5 x's here. Well, there's 1 x right here. So if our slope is 1, what would our rise be and what would our run be? 1 over 1. Good. So that means I'm going to go up 1 space and over 1 more space. And these problems are really nice whenever they just land on top of each other. My second point touches the first line already. I'm still going to connect the dots. Now, whenever you have a slope that's really small, like 1, sometimes it helps to continue that slope. I went up 1 over 1. I'm going to do that a few more times. Up 1 over 1. Here's another point on my line. Up 1 over 1. Here's another point. Up 1 over 1. Here's another point. Up 1 over 1. You could do this forever. Then I'll connect my dots. Okay, so I have both of my equations graphed, but I still need to know the system, the answer, the solution. I have graphed the system. I'm trying to solve it. What's my answer? Yes, I'm going to find the coordinate right here. That's where they cross, and I can see that this point lines up with 1 on the x-axis. So 1 is my x value, and negative 3 is where it lines up on the y-axis. So my answer would be 1, negative 3. Right. There it is. So that would be our answer for number 1. Okay. I'm going to go ahead and start writing number 2 up here, and we'll look at that one next. And again, as we go through these, if I ever write something down and you're not sure why, please stop me, call me out, interrupt me, ask questions, because if you are wondering something, odds are somebody else is wondering the same thing and doesn't want to say anything. So it's always great whenever you call things out. It really helps your classmates, and it helps me to know what I need to be teaching you more of. Okay. Okay. Any questions on number 1 at all? Is everybody ready to go to number 2? Okay, let's look at number 2. Now I have y equals negative 1/4 x minus 3 and y equals 5 over 4x plus 3. So where do I start for my first line? Negative 3. That's my y-intercept. So I'm going to go to negative 3 on the y-axis. Okay. Where do I go next? Up, -1. So if I'm going up -1, what direction am I really going? So it's either up or down. Down. Since our slope is negative, we go down. So -1/4. I'm going to write that. Rise and run. Rise over run. -1 is our rise. 4 is our run. So we'll start at our y-intercept. We'll go down 1. And how many spaces over? 4. So down 1, over 1, 2, 3, 4. That would be my second point. I want one of these worksheets, and then there's graph paper on the shelf. Okay, now I just need to connect those dots. So I'm going to take my ruler and do that. And again, it never hurts to repeat that slope. 4, 1, 2, 3, 4, up 1. I'll just give myself a third point. Okay. Now let's look at the second equation. Y equals 5/4x plus 3. Where do I start for this one? Three. That's my y-intercept. So I'm going to go to +3 on the y-axis. Right here. Now we're starting on +3. My graph only goes up to 6 here on this page. When we start counting our slope, we might see that we're running into a bit of an issue. If my slope is 5/4, that means my rise is 5, so I should go up 5. But here's what happens if I try to do that. 1, 2, 3, 4. I'm going off the graph. So I could still do it. I could just draw it off my graph, but there is another way that we can fit this on the graph without having to go off. So we have +5 over +4. A positive divided by a positive makes a positive. Can I use numbers with other signs to also get a positive? Negative. I can do a negative divided by a negative, and that's still a positive. So here's what we can do. What if I do -5 over -4? Watch what happens now. I'm going to go down 5, and instead of to the right 4, I'm going to go left 4, since they're both negative. So I'll start here. 1, 2, 3, 4, 5. And then I'll go over 4. 1, 2, 3, 4. And now I have a point on my graph. And you'll notice if I still did the slope up 5 and over 4, 1, 2, 3, it would be about right here. And those lines, or sorry, those points will all fall on the same line. So it's just a little cheat code or shortcut to not having to draw points off of your graph. So if your points don't fit on the graph, you can always do the reverse of your slope. So now I have these 2 points. I've got my lines. what is my solution? Perfect. Right here where my lines are crossing, this point lines up with -4 on the x-axis, so that's my x value. And it lines up with -2 on the y-axis, so that is my y value. There we go. 4, -2. Okay. Any questions on number 2? Okay. I'll leave that up for a second if anybody's copying it down. And I'm going to start writing number 3 down before we do that one next. Okay. I'm going to go ahead and move my page to number 3. So now we have 2 equations again. Y equals -7/3x plus 4, and y equals -1/3x minus 2. So we'll start with our very first equation. And what would our first point be on this line? 4. +4. Perfect. That's going to be our y-intercept. So it goes on the y-axis at 4. Okay. And where do I go from there? Perfect. Yes. -7/3 is my slope. So I'm going down 7 and over 3. So I'm going to count 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3. And there is my second point. So I will just connect my dots. So now the second line. What is my starting point for this one? -2. That's my y-intercept. So I'm going to start at -2 on the y-axis. And where do I go from there? Yes, my slope is -1/3. So I'm going down 1 over to the right 3. So down 1 over 1, 2, 3. Look at that. These are all landing right on the points. It's kind of nice. So I'm just going to take my ruler, connect my dots. And once you've got both lines drawn, where's my intersection? What's the answer going to be? 3 and -. Yes. 3 is my x value. -3 is my y value. So 3, -3. That would be my answer. Very nice. Okay. Start writing the next one. And we'll look at that together too. So 4. see. Y equals negative 2 over 3x plus 1, and y equals 2 over 3x minus 3. Okay. So, first line. Where's my first point go? Positive 1. Perfect. So I'll start right there on the y-axis at 1. And where do I go from there? Down 2. Perfect. Over to the right. 1, 2, 3. That's my next point. So my slope told me to go down 2 over 3. Let's connect these dots. I'm just going to give myself another few points using my slope. Okay. So I've got my first line, and now let's do the second one. Where's my first point for the next line? Negative 3. So I'll start there. And where do I go from there? Yes. 2 over 3 is my slope. It's positive, so I'm going up 2 over 3. Up 2 over 3. And we've got a nice little intersection right there. Okay, so what is the coordinate of my solution? Yes, 3 is my x value, negative 1 is my y value. Perfect, perfect. All right. So we've done 4 of these together now as a class. I know you guys spent a while doing these yesterday as well, so I'm hoping that this is more of a review for you all. But I don't know, how are we feeling since I was not here yesterday? It's hard to gauge it since I didn't get to teach it to you the first time around. Okay, good, good. Okay, now whenever we're looking at these, is there anything in particular that any of you are finding you're making the most mistakes on? Like, oh, I keep going the wrong direction for the slope, or I keep marking the wrong point as the intersection. Are there any of those things that we find we're struggling with?
I'm getting these, but I'm having a hell of a time with yesterday. That's a ticket. I don't know why, because it's the same stuff.
Right. So let me see. Let me pull up yesterday's exit ticket. Like, peek at it.
I'm doing.
It can be. It definitely can be. So this was yesterday's exit ticket. Let's just look at it for a minute. I'm not going to find your answer for you, but let's just talk about some things on it.
I did get a different answer, but I'm not sure myself.
Okay, so let's run through it. We have y equals 1/2 x plus 1. So where would I start for this line?
1.
At 1. Okay, so we'd start here. And where would I go from there?
Up 1.
Yep, up 1.
To the right 2.
Yep, up 1 over 2. Okay, so I've got these 2 points. Now, something that's going to help with this exit ticket in particular, because we're dealing with small slopes. Sometimes the small slopes make it really difficult to get an accurate line, because let's say I put my ruler here. Yes, I'm touching both dots, but whenever I look to see what points my ruler is really touching, here's where the issue is. Up 1 over 2. I'm going to do it again. Up 1 over 2. okay? Up 1 over 2. What if the intersection is one of these and my line doesn't touch that intersection? Drawing the slope more than once is always going to give you a more accurate answer. So instead of just 2 points, I would suggest at least 3, maybe even 4. So like this would be the first line. Now, if I look at the second line, y equals x minus 1, what would my starting point be there? -1. Okay, so I've got that. And then where do I go from there? My rise over run, which is, well, there's no number there. 1. 1x. So 1 over 1. So up 1 over 1. Okay, there's my second point. I think this is where it's tricky. On a lot of the ones we just did, usually the point lands on the line that we already drew. This one doesn't. I could connect these dots and it could look like, well, maybe this is the intersection. But maybe that is too. But maybe that is, I don't know. This is where using your slope to draw more points over and over is so helpful, because then you can know the answer for sure. So I started at -1. I went up 1 over 1. I'm going to do it again. Up 1 over 1. Okay, I'm going to do it again. Up 1 over 1. Okay, I'm still not there. Up 1 over 1. Whoopsie, we're touching the line. You could stop at that point. Now, I don't want to give you the answer, but
I got 4-3. Is that correct?
Yeah.
Okay.
That's right. You got it. Oh, I'm sorry.
My fault.
No, it's okay. You know, these are so easy to overthink. It's so easy to overthink.
That's what's throwing me off.
Right.
I'm trying to plot the extra points on the side.
Right.
Not to make it crazy.
And you know what? I think maybe whenever we do these in the future, something that's going to help, because I don't think I stressed it as much the first time, is I think we should always be drawing as many points for slope as we can, just so we're in the habit of it. A lot of us, whenever you did these, only did the 2 points and 2 points, and you got really lucky. You got the right answer. Or maybe you counted it in your head and just didn't plot the points. But whenever you are using something with a tiny slope, you can see how with only 2 points, my lines could be all over the place. But the more I give myself, the more accurate my answer will be. So I hope that helps you and anybody else that may have been struggling with it. So I appreciate you saying something. Okay. Is there anything else we may want to talk about before I tell you something else? Say it again. Yeah. How about this? Because I'm sure nobody got to this point, or if you did, great. I have other versions of this. I would like, now that we've done 4, kind of 5 together, go to numbers 17, 18, 19, and 20. I want you guys to solve these. Well, now 17 has kind of a special case. Maybe I shouldn't do that to you. Do y'all know what to do if you have x equals -3?
Yeah,
Vertical. So if you're not sure, we'll go over it when I set the timer and we go over it again in a minute. But do your best on that one. Do 17 through 20 by yourself. We'll go over them when the timer's over. Remember also what you can do if your slope is too big to fit on the page. Try reversing it, okay? Like on number 20, I can see that my y-intercept is 4, and I'm going to have to go up 8. That's not going to fit on our graph. Maybe instead try -8 over -3, down and to the left. So I will set a little timer. As you're working on these, feel free to work together, help each other out. We will go over them together as a class when the timer's up. I'm probably going to give you about 15 minutes for these 4. And Yeah, that's how we're going to do it. So I'm going to pause this and I will also be available to help. Okay, so our 15 minutes is up. Whether you finish or not, that is okay. We're going to look at these together. So I went ahead and wrote my problems out again on my graph paper. And we're going to start with number 17. So my first system is y equals negative 1/3 x plus 2 and x equals negative 3. So we're going to start by graphing our first equation. What would my starting point be? 2 plus 2. That tells me I'm going to start at positive 2 on the y-axis. And where do I go from there? Perfect. I'll use my slope, which is negative 1/3. That tells me, since it's negative 1, I'm going to go down 1, positive 3. I'm going to go over to the right 3. So down 1 space, over 1, 2, 3. There's my second point. Perfect. Never a bad idea to add more points to your slope. I'm going to do that again, down 1, over 3. And I'm also going to reverse it. I'm going to go up 1 to the left 3. Up 1 to the left 3. Just to give myself lots of points to go through. And I'll connect my dots. Okay. So there's my first line. Now my second line is different. X equals negative 3. How do I graph something like this where you're only given one variable? Over 3. Okay. So my x value that I've been given is negative 3. So I'm going to go on that x-axis and find negative 3. That's my point. And we're not given a y value here. So that means it doesn't matter what value I choose for y, my x is negative 3. I could draw a point here for x is negative 3. I could do it here. I could go down here at negative 3. I could do it anywhere as long as my x is negative 3. So what you'll notice is no matter how many points you decide to put on there, you are going to end up with a straight up and down vertical line going through negative 3 on the x-axis. If you'll notice, this is also how we used to write the axis of symmetry when we did parabolas. It would be x equals a number, and it was a line straight up and down. You didn't even realize it, but you were looking at a line that was graphed. So what's our intersection? Yes, right here, our x value is negative 3, and our y value is positive 3. That's our answer. Perfect. Perfect. Okay, let's look at number 18. My two equations. Let's start with the top one. Y equals 3 over 2x plus 4. Where do I start?
Plus 4.
Plus 4. That's my y-intercept. So it goes on the y-axis. Up 4. Okay, and now where do I go from there? Rise over run. My slope, what is my rise? What's my run?
Your rise is 3.
Perfect. My rise is 3. My run is 2. I'm going up 3 over 2. 1, 2, 3 over 1, 2. There's a point. We could also reverse it if we wanted to. I could start at my y-intercept and I could go down 3 to the left 2. If I reverse one direction, I need to reverse the other. And you'll see that that's going to still give us a point that lands on our line. Up 3 over 2. Let's do down 3 over to the left. See that? I could go down 3 again and over left 2 again. I could do it as many times as I can fit it on the graph. And now I'm going to have a really accurate line because I've given myself so many points. So we'll just connect these dots. Right. And now let's look at the next line. I've got y equals negative 5 over 2x minus 4. What would my starting point be? Negative 4. Good. So I'll start down here at negative 4. And my slope, what is my slope, first of all? Negative 5 over 2. So if I wanted to use this slope of negative 5 over 2, you would think, let's go down 5 and over to the right 2. But I don't have 5 spaces to move down. I only have 3. What could I do instead? Up 5. So if I decide to go up 5, what direction do I need to go to? Left. If I switch one, I switch both. So I'm going to go up 1, 2, 3, 4, 5, over 1, 2. Look at that. It's already touching. So let's connect these dots. And our intersection is our answer. So what is our answer? Yes, negative 2 is my x value. Positive 1 is my y value. So my answer would be negative 2, 1. Perfect. All right. And once we do these last two, I'll send you guys on your break. Don't worry. Okay, now 19 and 20. Get that speeded up. Now I have y equals negative 5 over 4x plus 2. And y equals 1/4 x minus 4. Where do I start from my first line? Positive 2. And from there, where do I go? Yep, down 5. 1, 2, 3, 4, 5. And then what? Over 4. 1, 2, 3, 4. There it is. Okay. So I went down 5 over 4. 2, 3, 4. Just going to give myself another point. Just for fun. I'll connect my dots. And when I start looking at the second line, what will my starting point be for that one? Negative 4. Okay, so there's my first one. Now my second one, negative 4 is my starting point. That's the y-intercept. So we'll start at negative 4 on the y-axis. Where do I go from there? Up 1. Yes. 1 over 4 is my slope. I go up 1. I go over 1, 2, 3, 4. There we go. So that will be my second line. I'll just connect these dots. Okay. And what is the answer for my intersection? 4, negative 3. 4 is my x. Negative 3 is my y. Perfect. Okay, last one. Y equals 8 over 3x plus 4. Where's my starting point? 4. Good. So I'm going to start at 4 on the y-axis. Now, I definitely cannot use this slope and go up 8 over 3. I don't have 8 spaces. Yes, so instead of going up 8 over 3 to the right, we're going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And what direction do I need to move 3? To the left. If I switch one, I switch both. So 1, 2, 3, right there. Okay, so I have my first 2 points. I'm going to connect my dots. Okay, and my last one. Where's my starting point? -2. And where do I go from there? Up 2 over 3. Up 2 over 3. I could also go down to left 3. Oh, and that would land right on my other line. Look at that. I'll connect my dots. And what is my intersection? What's my solution? Yes, -3 is my x value, -4 is my y value. All right, guys, it is about 10:30. So I'm going to let you have a little break. And let's just be back at, oh gosh. Let's say like 10:45-ish, 10:45. That gives us about 15. And then we're going to talk about one more little thing when we get back. And that'll be it. So enjoy your break. We'll be back in about 15 minutes. So we are back from our break. We've been solving systems of equations, and we've been doing that by graphing. But now I'm going to show you another way to solve them, because we don't always have the ability to graph equations. So let's pull out our notes, and I'm going to teach you something new today. So Algebra 2, Unit 3. And today is day 23. So these will be our day 23 notes. Page 1. Okay. April 30th. There's only 30 days in April, right? Isn't that crazy? It's going to be May tomorrow. That's nuts. I feel like it's just turned 2025. It's like it just goes faster every year. That's what they always tell you growing up, and then it starts happening and you're the one saying it. Just goes so fast. Okay, so I'm going to title this Solving Systems of Equations, and we're going to learn about another method to doing this. Solving systems of equations. Okay, so the first method that we learned about is solving them by graphing. So I'm just going to write that as our first method. solve by graphing. Okay, and underneath that, I'll just put a little description as a reminder. We graph both equations. Wherever those lines touch each other, that is our answer. So graph both equations. Graph both equations. The intersection is our answer. And I'm just going to put a little drawing beside it to help us remember. Just two lines. That point is the answer. You're going to get an x value and a y value. And the reason we're solving for an x value and a y value is because in our equations, there's not just one variable. There's an x and there's a y. So by graphing, we're really solving for both equations. We're finding the x value and the y value that makes both equations true. So there's two other methods we can use. We can also solve by substitution. Substitution. And then I'm going to leave myself two blank lines like I did there, and I'm going to write the third one. And we'll talk about these. The other method is called solve by elimination. Elimination. So there's three methods: graphing, substitution, elimination. And we've gone over graphing today. So next, we're going to talk about substitution. So because I'm just kind of making this list as a guide to reference, we're going to save this page. I'm going to go to the next, and we're going to talk about substitution before I actually give you a definition. That'll just make you confused. So I'll give everybody a second if they're still writing these down, and then we'll move on and look at this. Okay, I'm going to go ahead and turn the page. We'll come back to that page. We will come back to it, and I'm going to start titling this one. So again, Algebra 2. Page 2. Day 23, notes continued. Okay. So substitution. Bless you. That's what we will talk about today. So to solve using this method called substitution, I think one of the best ways to explain it to you is to show you an example. So I am going to pull the problem on the first page of that worksheet I gave you. We're just going to use number 1, which is y equals negative 5x plus 2. And the other equation is y equals x minus 4. Okay. So when we are trying to solve an equation, for example, we normally just have one variable. You might see something like, for example, I'm not going to write this on my notes. I'll do it on a little sticky note. Let's say I had here 12 equals negative 5x plus 2, just as an example. Using algebra principles for solving equations, how would we solve for x here? What would we do? Yes, we could start by subtracting 2 from both sides. Remember that equal sign separates the sides of our equation. And if I do something on one side, I need to do it on the other. I drew my line too high. So I'm subtracting 2 here, means I need to do it over here as well. So my 2's cancel, plus 2 minus 2, that's gone. Now I'm going to bring everything down. What's 12 minus 2? 10. Bring down my equal sign, and then I'll bring down negative 5 times x. So now, yes, we would just divide by negative 5 on both sides. And the 5's would cancel, giving us x by itself. I'll bring down my equal sign, and 10 divided by negative 5? Negative 2. So this is an example of what we would do if we only have one variable. Here we're not solving for y. But if I wanted to try to solve these equations, I really can't until I only have one variable to solve for. You can't solve for 2 at the same time. So here's what we're going to do instead. We don't have a number that we can replace y with like we did here. I put 12. I just picked the number. Instead of putting a number in for y, we're actually going to use the value that they give us. We don't know what the value is, but I know that y equals negative 5x plus 2, and I also know that y equals x minus 4. So what if I did this? What if I took this x minus 4? Because my second equation tells me this is equal to y. And what if I replaced it with that y? Here's what that would do. Now I'm going to rewrite my first equation, but instead of writing y, I'm going to use the y value they gave me in the second equation, which is x minus 4. So now we'll write x minus 4 instead of y, and then I'll rewrite the rest, equals negative 5x plus 2. Now, since I've replaced or I've substituted, that's why it's called substitution. Now that I've substituted my y for x minus 4, I only have x values. I only have one variable left. So what do we need to do when we're solving an equation that has a variable on both sides of the equation? We're going to combine our like terms. So all we're doing now is solving like normal. I'm going to get another color here. Let's do green. And I have two options. I could either add 5x to both sides, or I could subtract x from both sides. Either one would work. I'm always going to recommend getting rid of the negative. Because this x has a negative 5 on it, I would recommend adding 5x. If I subtract x from both sides, I'll end up with negative 6x. So let's avoid the negatives and add 5x to both sides. Okay. So I've done that. I've added 5x to both sides. What happens on this side of the equation with the minus 5x plus 5x? They cancel out. Perfect. So I don't have any x's on that side now. Now moving over here, what is x plus 5x? 6x. So I'm going to write 6x, and then we just bring everything down. Minus 4. I bring down my equal sign, bring down my 2. Perfect. Now I've got 6x minus 4 equals 2. This looks a little bit easier to solve now, doesn't it? What step could I take next? Add 4 to both sides. Let's add 4 to both sides. Okay, and what happens at this step? My 4's will cancel. Perfect. I'm going to bring down my 6x, my equals, and 2 plus 4 is 6. Okay, now we just have one last step. Divide. 6 times x, we want to get rid of the 6. So we're going to divide by 6. We'll do the opposite on both sides. And then what happens at this step? My 6's cancel. I bring down my x equals 6 divided by 6, 1. So using substitution, I just solved for x. Now I have an x value. So if I were to be writing a coordinate, that would be the x value of my coordinate. Let's not worry about that yet. Just know that we've solved for x. So now that we've solved for x, we still need to solve for y. Now, you can do this in 2 different ways. I can either substitute my 1 for my x in my first equation, or I can put 1 instead of x in my second equation. Both of them should give me the same answer. So I'm going to show you both just to prove that both of them will work. And let's use this. So the first step we did here is we solved for x. Now I'm going to take this x and let's start with the first equation. I'm going to write y equals -5. And instead of x, we're not doing times x anymore. What am I putting instead of x? 1. I just solved for x. It's 1. So I have -5 times 1 plus 2. Okay? So now I've got it plugged in. How do I solve for y? I've already got y by itself. Y equals. So what do I need to do over here? Yep, -5 times 1 is, it's just -5. And now I'm going to add 2 to that. What will that give me? -3. And look at that. We've solved for both variables. We didn't have to graph. It took us about 5 minutes. I think it's kind of neat that we can do that. But let's just also prove that we can use this equation too, the second one. If I were to do y equals x minus 4, instead of x, I'll put 1 minus 4. And what is 1 minus 4? -3. You get the same answer. So it doesn't matter which one you use. Once you solve for x, you can use either equation to solve for y. I would just pick whichever one looks easier. So to review the steps, we replaced or we substituted y with one of the y values. We basically set these other sides of the equation equal to each other. If I just cover up the y's, I really just did -5x plus 2 equals x minus 4. I just set them equal to each other. That's another way to think of it. So we've done one example. Let's look at another. Let's see. So moving on. Now let's look at, I want to find one without fractions. Okay, let's do number 6 on our worksheet. That one is y equals x minus 3 and y equals 5x plus 1. So again, the first thing we want to do when using substitution is we want to come up with an equation where we only have x values. So to do that, I like to take the y value, y equals 5x plus 1, and I'm going to replace it with the y in my first equation. So when I rewrite this, it'll look like this. 5x plus 1 instead of y equals, and I just copy down the rest, x minus 3. Okay. So where do we go from here to solve for x? We could add 3. Let's do that. Add 3. Add 3. Okay, and what happens now? My 3's would cancel. Yeah, 5x plus 1 plus 3 is 4 equals, bring down my x. Good. Okay, so now I have 5x plus 4 equals x. What could I do now? We want to combine like terms. We could subtract 5x. We could also subtract x. Either one is fine. Which one do we want to do? Sure, let's subtract 5x. And something you'll notice when you're solving equations like this that have multiple steps is you can do a lot of different things. I didn't have to add 3 first. I didn't have to subtract 5x. We could have done things in a different order. As long as we do it evenly, we will get the same answer. So I subtracted 5x from both sides. Those cancel. I'll bring down my 4 equals, and what is x minus 5x? Good, negative 4x. Okay, so now what do I do? Divide by what? Divide by 4 or negative 4. Yes, if I divide by 4, technically that would work, but I would have negative x left. I want to solve for x, not negative x. So I want to divide by this whole number that I have here, negative 4. And I want to do that on both sides. Okay. My negative 4's will cancel, giving me an x by itself. Bring down my equal sign, and then what is 4 divided by negative 4? Negative 1. Good. And we just solved for x. So now that we have an x value, how can I solve for y? Perfect. I'm just going to plug the negative 1 into either one of these equations. I'm going to start with this top one. It looks a little easier. Y equals, instead of x, I'll write my x value we just found, negative 1. That's my x minus 3. That's the rest of the equation. I'm going to put that in parentheses so we know that this is what x used to be, or this is what x is now. Oops. There we go. So y equals negative 1 minus 3. So what is negative 1 minus 3? Negative 4. So y equals negative 4. And these are your answers. X is negative 1, y is negative 4. Short and sweet process. It doesn't take too long. Sometimes it takes a little getting used to moving things around, especially when we haven't done something like this in a while. But it's not too long of a process, thankfully. It doesn't take forever. So let's do one more together. Do we have any? Yes. Yes.
Does it matter what, or when you're doing the big part of it, like the 5x plus 1 equals x minus 3, can those be reversed?
Yes, yes, absolutely. That's a great question. Let me explain that better with the next example we do, because that's a really good question. Let's see. Let me find another good one. Okay. Can I move this, or does anybody still need to see it? Okay, I'm going to move it. And I'm going to title my page one more time. Okay. So the next one we'll try. Let's do y equals 4x plus 4 and y equals x minus 2. So Amber asked, does it matter whenever you're replacing your y value with one of the other sides of the equations, does it matter which one gets written first? And the answer to that is no, it does not matter. I could do 4x plus 4 using this here and this equals x minus 2. I could do that. Or I can do x minus 2 equals 4x plus 4. It does not matter which side we write these on, as long as we're setting them equal to each other and keeping the signs consistent. I'm not changing anything to a positive or a negative. I'm just copying it down and setting them equal. Both of these will work. So let's go through this one now. I have set these equal to each other because I'm substituting my y value for the y that they give me. They said y equals x minus 2. So instead of y, I'm going to write x minus 2 equals. In this example, I have y equals 4x plus 4. So instead of y equals, I write 4x plus 4 equals x minus 2. So let's look at this first version that I wrote. 4x plus 4 equals x minus 2. What is something I could do first?
You can do 4x, take away 4x.
Take away 4x from both sides? We could do that, absolutely. So subtract 4x from both sides. Okay, and what would happen here? Yes, my 4x's would cancel. I'll bring down my 4 equals, what's x minus 4x? Good, negative 3x. Take away 2, bring that down. Good. Okay, what could I do next? I can add 2 both sides. My 2's will cancel. 4 plus 2 is 6. Good, I'll bring down my equal, bring down my negative 3x. And what's my last step? Divide. Good, divide negative 3 on both sides. My negative 3's will cancel, leaving this x by itself, and then 6 divided by negative 3. What is that? Negative 2. So I get x equals negative 2. Now I'm going to copy down on this side the other version where we set them on different sides of the equal sign, and we'll just show that we will get the same answer. It'll work. So over here, I'm going to do this one a little bit quickly. Let's see. I'm going to start with, I'm just going to add 2 to both sides. Okay. Bring down my x equals 4x plus 6. Subtract 4x. Subtract 4x. I get negative 3x equals 6. Divide by negative 3. Divide by negative 3. I get x equals negative 2. They both work. We get the same answer. It's the exact same steps, just written on a different side. Exact same. So now we have an x value, negative 2. How will I solve for y? Plug in the negative 2. So I think, let's see, which equation should we use, the top or the bottom? Let's do the bottom. There's less steps in the bottom equation. So I'm going to write y equals x minus 2. Instead of x, negative 2. Okay. So what is negative 2 minus 2?
Negative 4.
Negative 4. Perfect. So we have x is negative 2, y is negative 4. If you wanted to write these as one single answer, we would write this as a coordinate with an x value and a y value. So my x is negative 2, that goes first. My y is negative 4, that goes second. And if we graphed these equations, we would see that this should be the point where they intersect. Okay. So that's 3 examples now. And let's see. Do you guys want to try some on your own? You think you can, or you want to see another one together before we do that? You think you got it? Does anybody want to see one more together? Okay. I'm going to give you some problems then. So here's what I have. Printed off some more worksheets. Lots of practice problems. I'm going to come around and pass this out if I hopefully have. Oh no, I don't. I'm going to have to make more copies of this one. For now, I'm going to write down a couple of problems from this worksheet. Then I'm going to make copies of it so that you have access to all 20 of the problems. Because as of right now, I only have one copy. I copied the wrong thing today. So try the next few on your own, and I'll leave some notes up if you're still writing. So or help each other out. If you're confused, ask your classmates, see if they know what they're doing. If they're confused too, ask somebody else. Everybody should be working together. I think it really helps us to learn when we're teaching each other. So here is a few problems. Y equals 2x plus 3 and y equals 4x plus 3. y equals negative 2x minus 8. Y equals negative 4x minus 12. Y equals 2x plus 2. And 4. Okay. All right, I will pause this recording and I'm going to run some copies of that worksheet so that you all have access to it. So I've given you some time to try these on your own. And now I'm going to go over the answers with you guys. So let's see. This first one was, let me just rip this out. Okay, we have y equals 2x plus 3 and y equals 4x plus 3. So we want to solve for x first. How do we start this? We're going to set them side by side, equal to each other. We have a 2x plus 3 and a 4x plus 3. Basically, all we do in substitution is set these two equal to each other. 2x plus 3 equals 4x plus 3. Sometimes this is an easier way to think of it, too. We're just setting them equal. Okay, so we'll solve for x. What could we do here? Okay, so minus 2x on both sides. And those will cancel. So we'll bring down 3 equals 4x minus 2x. What is that? 2x. Bring down my plus 3. Okay, what do we do next? Perfect. We subtracted 3 on each side. Those will cancel. 3 minus 3 is 0 equals, bring down my 2x. I'm sure a lot of you got to this point and thought, what do I do here? We forget 0 is a number. Just treat it like a number. We can still do things with 0. How do I get x by itself here? Divide by 2. So I'm still going to divide by 2 on that 0. Perfect. So my 2's cancel. I've got x by itself, and that's equal to 0 divided by 2, which is 0. X equals 0. Perfect. So we've got our x value. How do I find my y? Yep, we're just going to plug it in. We could put it in either equation. It's going to give us the same answer. I'm just going to use the first one. Y equals 2 times x plus 3. Instead of x, we put 0. So 2 times 0 is 0 plus 3. What's 0 plus 3? 3. X is 0, y is 3. That's our answer. We could write it as a coordinate if we wanted to. 0, 3. X comes first, then the y. Perfect. All right, so there is the answer to the first question, number 1. Let's look at number 2. These down. Number 2, we had y equals negative 2x minus 8 and y equals negative 4x minus 12. So how do we start this one? The 4x minus 12, yep, we'll use this one, and you replacing it with that y? Okay, perfect. So I'm going to write negative 4x minus 12 instead of y equals, and the rest of that is negative 2x minus 8. So now I have my equation. Let's solve for x. What could we do here? Add 2x? Sure, let's add 2x to both sides. My 2x's will cancel. So now what's negative 4x plus 2x? Positive or negative? Negative 2x. I'll bring everything down. Minus 12 equals negative 8. All right. What do I do next? Add 12. Right? My 12s will cancel. I'll bring down negative 2x equals negative 8 plus 12 is 4. And our very last step, we'll divide by negative 2. Right? So those will cancel, and we will get x equals 4 divided by negative 2 is negative 2. So for number 2, our x value should be negative 2. So now we'll solve for y. And to do that, we can use either equation. I'm going to use the top one. So I'm going to rewrite everything. Y equals negative 2 times x. I'll leave it blank. Minus 8. What am I writing instead of x? Negative 2, the value we just solved for. So what's negative 2 times negative 2? 4. Positive 4. Minus 8. So what's positive 4 minus 8? Negative 4. We've solved for x. We've solved for y. That's our answer. As a coordinate, we could say negative 2 comma negative 4 to give us our x and our y. There we go. That's number 2. What'd you get for number 2?
Negative 2 and number 14.
Ooh, negative 14. So whenever you got negative 2 for x, let's look at your solving for y. You wrote y equals, and then what'd you have?
Negative 2 take away 12.
Negative 2 take away 12. Let's see. Did you use the second y equals equation?
Yeah.
Okay, so let me rewrite what you did. So y equals, we're using negative 4x minus 12. Okay, so instead of x, we're going to put the value that you found, negative 2. So when we rewrite this, we should have y equals negative 4. This means times negative 2 minus 12. So do you see what happened? Yeah. Negative 4 times negative 2 will give us positive 8 minus 12. And that is negative 4. So I wonder, what did you say you had written originally?
I put the negative 2 for the 4.
I gotcha. So just being super careful whenever we copy down equations, that's such an easy mistake to make. As long as you see what we did, then we're good. We're good. Any other questions or concerns about this one? Okay, I'm going to go ahead and flip and we'll look at number 3 real quick. Let's do that on the back of this page. This isn't really necessarily part of our notes. Okay, so number 3, I have y equals negative 2x plus 2 and y equals 4x plus 2. So same thing we've been doing. I'm going to set both sides of this equation here. I'm going to set these equal to each other. Negative 2x plus 2 equals 4x plus 2. All right, what could we do here first? We could add 2x to both sides. All right, so those will cancel. Bring down my 2, my equals. What's 4x plus 2x? 6x. Bring down plus 2. All right. What's next?
Take away 2 from both.
Good. Take away 2 from both sides.
Which will cancel out the 2.
That'll cancel.
6x.
Yes. 0 equals 6x. Divide by 6. Perfect. My 0 divided by 6 is 0. Equals, my 6 is canceled. I bring down my x. My x value is 0.
I got that one wrong.
What'd you get?
I got negative 2.
Negative 2.
Or 3.
Yeah, number 3.
Yeah, I got negative 2. Instead of the adding the 2x, I did subtract the 2 first.
Okay, so I'm going to write what you did. Negative 2x plus 2 equals 4x plus 2. So you subtracted 2 here first. Okay, so minus 2, and that cancels both of them actually. Negative 2x equals 4x. Okay, what'd you do next?
I divided by negative 2.
Okay, so you divided by negative 2 on both sides to give x equals, let's see, that would give us negative 2x, is that right?
Oh, okay. I just left it as negative 2.
Yes, because we didn't divide by negative 2x, we just divided by negative 2. So this is what it would look like. And then from here, well, I guess we would need to add 2x or subtract x. I'm going to add 2x. Since those cancel, we have a 0 here equals 3x. When I divide by 3, I'll get x equals 0. Yes. Anytime we end up with 0, the equation always feels harder. I feel like it always feels uncomfortable. So that's all right. We get x equals 0. All right. So then to solve for y equals, I'm going to use the second one, 4 times x plus 2. Instead of x, what do I write? The value we found, 0, good. 4 times 0 is 0. So y equals 2. There we go. And I do realize that it is 11:55. If you are needing to get out of here, you don't feel like you're being rude. You can go if you need to. I'm just going to finish going over these. But if you need to go, that's fine. So as a coordinate, it would be 0, 2 for x and y. Okay. Then we got one more, number 4. Can I move this? Okay. You still looking at this, Misty? Or do you have a question? Okay, perfect. All right, so last one. See if I can fit it on here. Number 4, y equals negative 3x minus 5. Y equals 3x plus 7. How do I start this problem? 3x and 7. And what are you doing with this? Putting it where this y is. We're going to replace that. So instead of y equals negative 3x minus 5, 3x plus 7 equals 3x minus 5. Okay. So what do I do next? Yeah, let's add 3x to both sides. Okay, those will cancel. 3x and 3x make 6x. Bring down 7 equals negative 5. Good. Okay, now what? Sure, we can do that. So add 5. Okay, add 5. Those cancel. So if numbers cancel and there's nothing else left, what do I need to write over here? 0. I can't just have an equation with nothing on both sides. So those give us 0. 7 plus 5 is 12. And then I bring down 6x plus 12 equals 0. Where do I go from here? Subtract 12. Those cancel. I have 6x equals negative 12. Divide by 6. And I get x equals negative 2. Good. X equals negative 2. Okay, so now I just need to solve for y. So I'm going to use the second equation since it is positive numbers. I'm going to just rewrite it. Y equals 3. Leave a space for x plus 7. What am I writing instead of x? Good. Negative 2. 3 times negative 2 is negative 6. Negative 6 plus 7 is 1. So x is negative 2, y is positive 1. Woo! Lot going on there, you guys. It's 5 minutes past. You guys are free to go. Absolutely. This is the exit ticket. If you have not seen it yet, it is up at the front of the room if you want a copy. Right there, you're just going to solve this one system of equations. It's not due till Friday, but that is all today. This.